Alright. Well, I think it's no news that this year everybody's talking about AI. Every product, company, conference mentioning AI. It's basically a bet if you want to get drunk. Everybody's talking about it, right? But what can we do from our perspective as JavaScript developers instead of just looking what they're doing? How can we be part of it? How can we create stuff? So today I'm going to talk about how you guys can implement machine learning into your web, mobile, or any JavaScript applications you have. So my name is Aileen. I'm from Mexico. I just arrived this morning. I hope I'm still good to give this presentation, but really happy to be here. It's my first time in Japan, and I hope you find this insightful. So for the agenda today, I want to talk about these main things, which is basically give an introduction. I want everybody to be on the same space of knowledge of these concepts. We're going to talk about why would we use machine learning, and then talk about TensorFlow models. We'll do some demos. We are going to see some use cases. And finally, what's new? Just want to mention, this is not new, but there's a lot of updates that can help us in implementing our JavaScript applications. So let's start with the basic, which is AI and machine learning. So AI, or artificial intelligence, the science to make computers act like humans, right? That's basically what it comes from. That's basically what envision about it. It's a theory to build machines that think and act like humans. But how do we accomplish this? And this is accomplished with machine learning. And machine learning is basically how the machine gets to think, right? As developers, we usually code, we get a requirement, we code it we get an input that can come from a database, that can come from a file, and we define the rules. So we say, get these, consume the API, and show something. And that's how we usually program. But machine learning is really different about how we usually program. We need to give the input, we give data, but we give the answers. We're going to say, let's say if you want to implement something regarding recognizing something, how would you code a recognition of an object? Sounds very complex. You'll need to do a lot of if switch, something to cover every piece of it. So machine learning is different. You'll just say this image or this audio or this code is this, and then the algorithm itself would learn and predict and give the answer. So it's the other way around. We don't say to the machine what to do. We just mention these are the rules. This is my input. And then get the model. The model is the outcome of all this training. There is a course from David Brook. He has a course about TensorFlow certification. And he mentioned it's like a magic oven. You just give the recipe, you give the ingredients and a picture of how you want to look, and the oven would give out the recipe. So it's the other way around. And it's a really interesting paradigm, but this is how it works. Okay, so we cover our bases. Let's see why we want to use machine learning and why with TensorFlow.JS. I know this is a JavaScript conference and maybe you don't need to know this, but basically JavaScript runs pretty much everywhere. This is the 11th time in a row where in a Stack Overflow survey, JavaScript is the most used language across the world. So there's a lot of developers using JavaScript, and it gives an open door to do more with more people that have this talent. We can use it on the web, we can use it in a desktop application if we use Electron, we can use it on the server with Node, we can use it with IoT if we put it in a Raspberry Pi, and we can do it with mobile if we use React Native. So we could use JavaScript everywhere if we wanted to. So as I mentioned, it's an open door to create more things with this language. Okay, so I know I didn't need to convince you to use JavaScript, but why TensorFlow? TensorFlow is a Google open source library. It's not new, but it has a really big community, and it's backed up by Google. So this gives a lot of kind of security that this is up to date. There's actually yesterday, I believe, they released a new version. So it's been maintained, it has a big community, and it's the only one that has a certification. The other thing would be PyTorch. Both are great, but today this is the one that has a JavaScript implementation. This library helps you because it gives you 3 layers, depending on what you want to do. If you just want to use already pre-trained models, you have them available with TensorFlow. If you might need to modify, do some fine-tuning to your model, TensorFlow.JS library helps you with that. And of course, if you want to optimize the models that are already available, you can do it with TensorFlow. So depending on what you want to do and the knowledge that you have, there's a way for you to get into TensorFlow and use it. What can you do with TensorFlow.js library? You can create a model from scratch, and we'll explain. I talk about models a lot, but we'll see about them. You can train them if you already have one, but you need to classify with something new. You can train them or just run them. There's already pre-trained models, and you can just plug and play to your whatever application you have in JavaScript. So it gives you the leverage of whatever you want to create, you can do it. And of course, since it's with JavaScript, it uses npm. So it's a great way to package things. But if you also know JavaScript, you can also implement it on the server with Node. So it's the same. If you have an application that runs full stack, as I mentioned, you can also run it on the server, but also have the ability to run it in the browser. So if in your company you only have JavaScript developers, that wouldn't be an issue. You can share that knowledge and create a full stack application with it. Privacy. This is only if you run it on the browser, of course, because let's say, and this is actually used right now, Airbnb use TensorFlow.js to identify stuff like password or anything that it's required with legal content. So that way you don't save that information. The model will just recognize what it needs to recognize, but you won't send that information back to the server. It stays in the browser. So this makes it more private. And we have to be very careful with data that we test with our models. So that's why it's a great way to use it. If you need to check legal, x-ray, medical documentation, this is very delicate information. But if you're in the browser, you're not sending it anywhere and not storing it. Unlike if you had it on the server, you'll need to manipulate the data. The other part is the latency. If you have your model on the server, you need to go and fetch stuff. But if you have it right there where you have your code, for example in the browser, you have a microphone API, you have a camera API. If you run it on your phone, you might have other sensors available, something that you won't have available if you have it on the browser. So this also gives more capability into what you can do with your models or how to use them. Also, it's cheaper because you're not running it on any server, you don't have to pay for it, you're just running it on the browser. Of course, this is talking about running it on the browser. If you have your application, well, if you need to serve that web app, you need to pay only for that. But you don't need to pay any storage. Usually that is how models run. And finally, you can run it offline. This means that not everybody has a 5G internet connection. Sometimes if you're using your model to recognize something out there where there's no signal. So this is a great way to implement if you have these concerns about where are you using this application. So these are the benefits of using TensorFlow.js in general. And let's talk about the models. I talked a lot about the models, but let's see what they are. So as I mentioned, you can run them, and remember the model itself is the outcome of the training of the outcome of the training of the machine learning that you want to do, right? So you can run existing model, retrain them, or write them from scratch with Node or JavaScript. And also TensorFlow, it's not only with JavaScript, it has a Python version, and it also has a mobile version, which is TensorFlow Lite. And there's this ecosystem. And the nice thing about this is that if you find a model in TensorFlow Lite or in TensorFlow Hub, you can convert them to JavaScript. TensorFlow.js is the only one that can get those models converted. So if you find a model in the other environment that you have there, you can transform them. There is actually a TensorFlow converter, so this makes it available and super cool to use any model. And there's many ways that you can train your models. So this is just general. There are more ways, but these are like the most used ones. Supervised learning. And supervised learning is, there's more, but the most common ones are regression. And regression is mostly used, for example, if you want to predict a number, let's say the cost of a house. So the outcome would, you train your model, and the outcome would be a number. The difference with the classification one is that the output would be between 1 and 0, right? You're saying, I have these classifications, what is the probability that it got into each of those classifications? That's the main difference between a regression and a classification model. The other ones, and also the supervised need a label. When you train these models, you need to label them so they know how they get into each of the features or each of the classifications that you're running in. Then the unsupervised one, that is, you have a lot of data, what do you do with it? The algorithm would identify stuff, and this is very commonly found in banks, for example, for fraud. So they know your habits, they know where you buy, they know what you buy. So if something is out of the ordinary, that's what these machine learning, unsupervised learning models work for. The other one is clustering, which is the other way around. It's finding patterns between all the data and putting it together so you can see some clustering. And this is very commonly used if you buy in Amazon, when you get something suggested, this is how this works. Or maybe on Netflix, like, you already watched this. So that is the unsupervised learning. And the other one, really commonly used too, is the reinforcement one. And this is more about trial and error. What this means is like, for example, Roomba, if you have used any of those, or it's also very commonly used with robots or with gaming. This is, you give something back to the machine and let them know that, yeah, that works. And that's how it learns. And it's also very commonly used on chess. So as I mentioned, games or anything that needs not a specific pattern, but knows different ways to do it. And these are the ways that you train them. That is how it differs from each other. And so the models that we have available right now with TensorFlow are these ones. The first one is the vision, which is the image classification. You can just use them. Creating a model, it's complicated because you need data. And if you have the data available, that's great. But if you don't, we need to be very responsible about how we train our models and how we use them. I've heard once, it says, the data that you train your model in is the world that is going to work. So if you don't train it with a lot of the information that is missing, it's not going to work in the real world. So that's why it's good that TensorFlow has all of these models available, because they have already researchers that have gathered this data. So, I mentioned vision, image classification, and object detection. The difference between them is that the object would identify where that object is, but they're all classifying the items in it. There's the human body. This one is commonly used, the body segmentation, people usually use it for gym routines and all those things. There are many ways you could use them, but some of the ones that are being used: pose estimation, face landmark. If you're using your application and you need to recognize a face, that's a great model to use it. And the hand pose. This is very commonly used for sign language. The other one is text, it has text toxicity. It's already been trained with different, I think it's 5 classifications about an insult, and threat, and many other categories. So it's really great if you want to moderate something in a web application. This is a great model to use. Sentence encoding, verb Q&A, conversation intent detection, and the other one that is very commonly used is sound. So if you want to work with sound, this is a great model that you can use. It has some classification items already, but you can retrain it to use it whatever you want. So I think it covers most of the things that you might need. But of course, there are other places like Hugging Face where you can find more. But today we're talking about TensorFlow, and these ones are the ones that are available. And so we mentioned already models, trained them, but how do I get started? So there is a machine learning workflow. And the first thing to identify is what is the best algorithm for your model and for your use case. Because usually when you create models, there's a lot of try and error to see if you're using the right loss function or if you're using the right structure of data. So you need to find first that one, and then for your use case, you'll know what to use. If you're training it from scratch, you need to find the right data. As I mentioned, you need to be very responsible with that. And there's great places that you can find data sets. Kaggle is one of them, and Hugging Face. They have cards that certify where the data come from and are open source. So those are great places that you can take to train any model. And then, once you have enough data, it's very important to take all of this data and divide it. You need to test data and then verify that the model, once it's training, it's gonna work as expected. And finally, you deploy your model. These are basically the steps for you to, if you want to start creating a model, this is how it's done. So we cover most of what it is. Models, I want to showcase some of code, so to see how all of this is working. So let me just show you. So there are many ways that you can add TensorFlow to your applications. This one is with NPM. You can add them. This is for an application for Node, for example. You first install the TensorFlow.JS /node. You can select where to or how this model is going to run. In this case, you can use it with Node GPU. And there's these models that you can install via NPM too, like the MobileNet. Let me just change this. All right, so we can see all of this. Okay, so there's as I mentioned, you can use TensorFlow, but there is another way that people with no coding experience can use, and this one is called Teachable Machine. This is a tool created by Google where you don't need to do any code at all. You will get some code. But to get started, you just select if you want to use an image project, which would be an image model, if you need an audio project, or if you use a post project. You use an image, you can say standard image, and then you can name the classifications here. You fit it in with the data that you want, it will train it, and what you get is this. This you can just plug and play it to your application and it will work. I created one that would identify a dog or a cat. Just okay, not working. All right, I'm just gonna use a random cat. Oh, something's wrong. It's not letting me choose. Okay, if you want to try it, you can just do it that way. I'm not sure why it's not working here. But anyway, what I did was basically, when I trained that in Teachable Machine, it gave me two URLs. One is the model URL and the other one is the metadata. Every time you create a model from scratch, you hit model.save and it would give you a JSON. That JSON is the one that's gonna be running on your browser and it will do, that's why you can run it offline. I load my model and I give the image to it. And then once I have my model and my predictions, because we're always talking about predictions here, I'm gonna pass in the image, so I have the model, it has a function called predict, and I'll pass the image there. And here I'm gonna receive a class name, which is a class that I defined when I was teaching it. And then I'm gonna log out the probability. So it's gonna put me between 0 and 1. So I would know the probability of each of the classes. And in the end, it would throw me the answer on it. This is with no code at all. But then there's other options where you actually can use code there. This one is an Angular application that I created that uses CocoaSSD, which is an object detection model. So let me just open here. Here. Okay, so I have here my load important from CocoaSSD. As I mentioned, these are available on NPM. I'm importing the library itself for TensorFlow. And then it works very similar like the other one because it's using the same model. But I'm here using the model as a function. So I first need to give TensorFlow the items of how they can read them. So in this case, I'm using, thank you.
Okay. Challenge.
I'm using the image and I'm using it from pixels. This would give the TensorFlow library how it can read. Remember, it cannot, it's not a person that can identify, so we need to give a way it can identify the image. So now I have here the TensorFlow image. I have my model, and it would, again, I'm using the detect function from the model. I have my predictions in here, and then for each, I'm gonna draw a border on each of the objects that it detects. So let me show you how it works. Oh. Let's see if this works. Sorry, technical issues. Maybe it's in the other way. It allows me, it's not popping up stuff. So I have some index HTML in order not to serve it. I just use this simple web server. Okay, here it's. I'm not sure why this is not working. see if this works. It's just not opening any.
Restart call.
No, that's wrong. Let me try it. Put it. Sorry, guys. Shooting right now.
I'm here.
Yeah. Thank you. So sorry, needed to restart from stuff. Okay, so this is the Angular application. I have the Cocoa SSD, and then I'm gonna select this image. And as I mentioned, I'm drawing a square on each of the objects that it's displaying. It's gonna take a while because this one is a model that I'm importing. That's the difference. If you import it, it would take sometimes. You cannot use it offline. But if you create a model, you can just put that JSON file on your file. Let's just wait. So here it detects 1, 2, 3, 4, 5 persons, and it's drawing them, and it's displaying the probability that it found on each of the objects. It has wine classification class. There's more stuff, of course, in that image, but Cocoa SSD has only 80 classes. If you want to add more classes, this is when you want to retrain it, right? You already have that model, you just need to add something else. So it's already have the capability to do that. This is a Cocoa SSD, as I mentioned, the difference between the image and the object. This will tell you where exactly, and the other one will just classify that it exists there. And then the other one is the context classifier. So I just did a very simple, I just plug and play added the toxicity model, and then I'm gonna add something that would be categorized as bad, and I'm sorry for the word here. But if I write stupid, and I click classify, I get the first label of insult, the probability is of 98%, and it's classified as true. It's not an identity attack, it's not obscene, but it is toxic. The last label is toxicity, and it has a 98%. So these are the categories that it can classify all of this text that you write. And as I mentioned, if you want to use it for controlling the language in some places, this is a great way to do it. I'm gonna try to go fast because I'm running out of time. All right. So, what's new? So in this Google I/O, I'm not sure if you see it. Sorry if you saw it. We have WebGL in our browsers, so you can run these models. You might say, why would I run a model on browser if it's slow? Google invested a lot of money in making available WebGPU. What does this mean? You can run stable diffusion models in 10 seconds. It would create an image in 10 seconds. So that is a lot of capability that it's now delivered. You don't need any experimental web browser, it's available already. It also depends of course, where are you running these models. So the default one is CPU, the one that the user have. WebGL is good, but it's not as good as the new one that we have available. And then of course, WebAssembly. Google has invested a lot in WebAssembly. There's a lot of solutions created over it. I think there's a lot of potential there and a lot of things that are going to be created with WebAssembly. But this is great news. As I'm not sure if you saw also, Photoshop, they have this new application on the web that is using TensorFlow.JS on the web. So there's a lot of investment in people using it. This looks very small, but I'll explain this. TensorFlow, this is how it was in March this year. There is it has grown 10 times since 2020. The downloads of TensorFlow.js from npm. It's 230,000 weekly downloads, and it has a cumulative amount of 50 million downloads. And it's growing. This is a graph of people using it, downloading it, TensorFlow.js from npm, and it's just going up. The part where it's down is because it's holidays. So if you have heard also about Hugging Face actually changed one of their models from Python to Node because Node is fast. So there are a lot of use cases, and they have a blog where they explain why they did that change using TensorFlow.js. So there are benefits and places and use cases where we'll want to use those models with Node or JavaScript. So if I want to use them, a model with JavaScript, what are the use cases that might fit in this solution? First,
we only have 1 minute.
Okay, models that are available. If you need to retrain models, or if you want to write them from scratch but have them available on the browser. And I just want to finish with JavaScript is not a replacement for Python. PyTorch will exist. The only thing is that they can live on the same place, but you as a JavaScript developer can get into AI and machine learning with TensorFlow.js or Transformer.js. So that's it. I hope you like it. If you want to know more about this, there are some great books from Jason, a course from Jason Mays. He's the developer advocate from TensorFlow.js, and some great books from Gandalf, Charlie Gerard, and of course Lawrence Moore. Thank you.
Thank you.